Everyone. My name is Mariah Vertulfo. I go by Maya. My pronouns are she, her, and I'm a master's student at Portland State University. I'm studying environmental science and management, and my research study is on analysis of harmful algal blooms in the lower Willamette River in Portland, Oregon. A quick introduction on the Willamette itself. It's popular for recreational activities, specifically swimming, boating, and fishing. There's always people along the river. Public concern for its water quality has increased despite the reduced levels of bacteria such as E. coli, and the changes in summer temperatures annually are likely to drive increases in cyanobacteria, therefore increasing the risk of harmful algal blooms. We performed a pilot study using samples from 3 sites along the Willamette: Fire Station 21, Audrey McCall Beach, and Selwood Riverfront Park, which are in proximity to Ross Island Lagoon, an urban tributary that experiences harmful algal blooms quite often. Here we have a Google Earth image of our sampling sites. Downstream of Ross Island Lagoon is Selwood Riverfront Park, and upstream are Audrey McCall and Fire Station 21. The objective of this study is to focus on quantifying microcystin, the most commonly tested cyanotoxin, and connecting it to the potential risk or harm to public health. As for our methods in experimental design, we use solid phase adsorption toxin trackers, which contain a specific resin that would absorb cyanotoxins from the water. We deployed these spats at our sampling sites. 2 were placed at each site to satisfy duplication and left there for about 7 to 8 days. Here we are attaching the spats to a floating dock, so then we don't have to worry about the tides constantly changing. Once these spats were retrieved, the resin was taken out of the spats and transferred to chromatography columns and flushed out 3 times with 50% methanol, therefore separating the toxin that we're looking at and leaving only those in our samples. And each sample was diluted at a 1:10 ratio to prevent high readings that we wouldn't be able to observe or analyze. For analysis, we used an enzyme-linked immunosorbent assay, or ELISA kit, to read raw absorbance values of each sample, their duplicates, and their dilutions. The standard curve parameters and sample concentrations were graphed and calculated using an Abraxas solver. In addition to our sample data, we're also looking at USGS data, current and historical data, on water quality parameters, specifically temperature and microcystin, because we want to observe how temperature may be influencing microcystin concentrations over the years. And this data can go all the way back to 1975, so it can give us a pretty good idea of what's happening in the river. Here, using the current conditions portion of the USGS website, I have extracted or produced a graph of chlorophyll and temperature. During the same time period, you can see that there's specific or certain peaks in chlorophyll concentration, and the peaks in temperature correlate with that or seem to match. They seem to have a relationship going on, which supports our question that temperature is influencing harmful algal blooms or algal blooms in general in the Willamette. Based on our sample data, we have determined that the presence of microcystin is greater in sites 1 and 2. This means that they're greater at Fire Station 21 and Audrey McCall Beach. The error bar in Selwood is large, but there can be a lot of things that can contribute to that. One being experimental error, maybe there was something that happened in the lab, or natural occurrences that may have influenced data collection, something that messed with our spats, or it can also be explained by Selwood's position on the map. As we saw on the Google Earth image, Selwood is downstream of Ross Island Lagoon, and these 2 sites are upstream, Now the Willamette is unique and flows northward. This would mean that any cyanobacteria blooms that occur in Ross Island Lagoon, any cyanobacteria present, they'll be washed upstream to these sites instead of downstream to Selwood. So that may be an explanation as to what happened there. And using this information, we determined that temporal sampling would be a better choice when considering resources and time, and also it would show a better comparison of how temperature changes and seasons influence algal productivity and algal blooms in the river. An analysis of the temperature influence as well as a social survey on water use would be the focus for next year, as well as a stronger connection to climate change and its impact on water quality in general, algal productivity in the blooms, as well as nutrient cycling in the river. And here we have our references and special acknowledgments because this research project was made possible by the USGS and Portland State University. Special thanks to my PIs, Dr. Jen Morse, Dr. Alyssa Starry, and Jennifer Morass from USGS for their constant support and resources. Also, special thanks to Laura Jansen for her training and Dr. Eugene Foster for his advising on water policy. Thank you.